will be available on our website. Just before I hand over to Niels, I just want to give a very quick overview of the programme. So it's a 4-year, sorry, just somebody's just trying to phone, excuse me, it might be about the webinar, just a second. I can't speak to you. Very sorry about that. Yeah, just briefly then, an overview of the programme. So it's a £4 million 4-year programme funded by NERC, and the aim is to carry out research on hydrological, sediment and geomorphological processes and flood modelling. So overall, the aim is to improve our understanding of the suitability and effectiveness of different NFM measures for a range of flood risk scenarios and at different scales. There's 3 projects that comprise the programme. Landwise, which is focusing on lowland catchment around the West Thames. There's the Protect NFM project, which is focusing on headwater catchments, particularly in the Peak District, and our last webinar covered that project. And the third project is the QNFM research project on upland catchments in Cumbria. So there's a number of case studies, and the outputs from the programme will inform the NFM web evidence base and help policymakers, businesses and local communities make the best use of NFM measures. So stakeholder involvement is a really important part of our programme. So there's a slide just showing people and organisations we're working with. And whilst Niels isn't directly involved in the research programme, one of the goals of the programme is to allow and encourage people involved in NFM to share their knowledge and experience. So Niels is an independent advisor, and he specialises in soil health, grazing management and whole farm planning, and he provides training for farmers, land managers and advisors. His background is in agroforestry design, and he carries out farm monitoring and research and works across the UK. So I'll now hand over to Niels. Able to share your screen, Niels? I can't hear you, Niels. Is your microphone muted? You need to unmute your microphone. It's still red, I can see actually. If you just click on the microphone symbol and it should then enable it. I might be able to do it. Okay, I've done it. Can you try speaking now?
Okay.
Oh, good, yeah, we can hear you now.
Thanks for that. Okay.
Need to go to slideshow.
Can we see?
You're breaking up. Hello, Niels. I can't hear anything, Niels, from you at the moment.
Just let me know when you're good to go.
Can't hear you, Niels.
Sorry, Gerard, am I ready to go?
Yeah, you're ready to go. Well, yeah, fire away.
Right. Okay, so just take
Steve,
Gerard, if you want to mute all the participants.
Sorry, I can hear a couple of people talking.
Yeah, if you just want to mute them, you can do that, Gerard.
Yeah, okay.
Brilliant. Okay, so yeah, I'm just going to take you through a fairly brisk introduction to soil health and how it relates to natural flood management, and we can take some questions at the end. So, as Gerard mentioned, I advise farmers and landowners primarily to help them to select novel practices and apply the soil health principles in the field, and to set up trials as well as carry out their own monitoring through apps and their own techniques. So just the sort of broader context to this work, the sort of overarching panel would be this idea of regenerative agriculture.
It's not very clear, the sound. Is it connected well?
Yeah, I don't know. I'll try without the headset.
Yeah, it might be easier without.
Can you hear me okay now? How's that?
It's similar. There's a bit sort of echoey sound. I mean, you can hear what you're saying. Perhaps that's the best we can do.
I'm going to try a different headset. Yeah, well, I'll just kind of introduce this heading, but do give me feedback, Gerard, on how the audio is as we go along. So if people are missing anything, I think it's important that you get a heads up. Try a different bit of technology, see how that works. Any better, Gerard? How's that?
I can certainly, yes, it's probably slightly better. It's certainly, I can understand what you're saying, so probably best just carry on. Yeah.
Okay. Yeah. Well, again, apologies if the audio isn't 100% clear. So basically, the kind of overarching sort of context to this is this idea of regenerative agriculture. So, when we introduce this idea, then it's important to understand why regenerative and not sustainable. And it's quite a frequently used quote now, basically. But, if somebody asks you how your marriage is, would you say, oh, yeah, it's sustainable? Well, generally speaking, I think we want to be aspiring to beyond just sustainable, if you like. And often, we may be starting from a lower base point than is ideal. So we need to raise the condition of the resource, the soil and the land above that. So just to give you some very brief definition of regenerative agriculture, it's a system of farming practices and principles increases biodiversity, enriches soils, improves watersheds and enhances ecosystem services. Aims to capture carbon in soils and above-ground biomass, reversing the current global trends of atmospheric accumulation, known as climate change, and at the same time it offers stable, profitable use, cutting costs and reducing inputs, bringing resilience to climate instabilities with higher health and vitality for farmers and communities. And the system draws from scientific and applied research from around the world. So what's the sort of broader imperative? Why should we be particularly concerned about this now? Well, there's a couple of examples here. The photo on the top left is 2 degrees of climate warming, global warming, and the bottom right is 4 degrees. I think we can both generally concur those are both concerning issues. So we could generally say that climate change, for the context, is the breakdown of 4 ecosystem processes. Number 1 is the carbon cycle. Number 2 is the water cycle, which we'll focus on quite a bit today, as well as that nutrient cycles and this idea of biological community dynamics. So we can look at the carbon cycle as the photosynthesis cycle, solar energy flows. We have energy coming into the system being transferred into sugars, and that's being brought down biological system. So every year we're drawing down carbon dioxide from the atmosphere powered by solar energy, and then every year, at the end of the year, a portion of that is released back to the atmosphere. Fine, that's a very good system. It keeps our planet warm, but we're also adding to that through fossil fuel production of cement and also through land use change. Yeah, so we've contributed a significant amount of additional carbon, which is basically leading to a net warming of our climate. The next one I'll look at is mineral cycles, and this particular example is the nitrogen cycle. But generally speaking, particularly with nitrogen, we are overloading the system, putting too much nitrogen by our synthetic inputs, for example. And if you overload the system, it can't cope. That's the primary take home. Same with climate change. Too much carbon, and you change the balance of the system. What we want to be doing is tapping into those natural cycles, that natural processes, our management. Then the final one, we'll move on to the specifics today. This idea of biological community dynamics, and basically to say that the more species in a system or in a community, the more resilient and the more stable that system tends to be, and particularly resilience against shocks or stresses, climate ones, as the number of species increases, the diversity increases. Okay, so the one most pertinent to us here is the water cycle. And again, contrary to popular belief, the rain does not mostly fall on the plain. The rain mostly falls on the high ground after it's moved in from the oceans, for example. The sort of eventual sink for this water. And water that we can see in streams and rivers should have always passed through some kind of soil filter, interacted with some kind of biology. And in that situation where you have good infiltration, as you can see over here on the right, then that leads to groundwater recharge and a steady increase in water levels. However, what we're seeing this week and sort of the last few weeks and sort of regularly over the last few years is excess water finding its way into the valleys and causing flooding. So this is in Mid Wales last week, where you have lack of infiltration. You have a lot of runoff, basically. When you have excess runoff, that water finds its way straight into the rivers and streams. The capacity there just is insufficient to cope with that volume of water. We've got two examples here. On the right-hand side, infiltration was measured at over 20 minutes to infiltrate 1 inch of water. On the left-hand side, it took 7 seconds to infiltrate that amount of water. So the result, where we have poor infiltration, is chaos and disruption, damage to property, flooded homes, and then also, like we had in 2018, drought. And this is the key thing, where infiltration is insufficient, water that does fall on the land, it's shed, it's not absorbed, it's not there then for germination or growing grass in the season. So where you have poor infiltration, not only do you have flooding, you also have drought. Two sides of the same point. Okay, so what are sort of our key objectives with regards to soil health? In this case, we want to encourage water to enter the soil profile. We want to store more water in the soil, increasing that water holding capacity. We want to keep water on the hill. We want to even out those flood pulses. But basically, we can say that soil health is a part of this regenerative solution. And I also like to love these presentations as sitting down and looking at pictures of soil. Okay, so the first one we'd like to look at is a couple of soil samples here, both spade samples. On the left, you can see kind of blocky, cracked, pale soil. On the right-hand side, it's quite a dark brown soil. And normally, you can ask people if I'm delivering a session, are these the same soil type? Obviously, you can see they're quite radically different in their appearance. In this case, yes, they are both the same soil type, from the same field, taken on the same day. On the left-hand side, arable. On the right-hand side, grass margin. And if clients with us today, you might recognise this soil. Okay. So similar comparison here on the left-hand side, we've got an arable soil. Again, you can kind of see sort of angular features, sort of jagged edges along here, for example, quite blocky, lots of faces, again, quite pale. You compare that to the lawn, just a few metres away, it's a totally different colour and texture. Same soil type, but different management. We can basically infer from that that management in soil health, one of the key drivers is soil health. Yeah. So how can we see soil health? How can we tell what it is? Ultimately, if there is one master indicator of soil health, we can say that it's crumb structure or aggregation. So those rounded, bobbly shapes that you might see in that friable loose soil that we all aspire to, something similar to mini earthworm casts. Where does that come from? How do we kind of use that sort of real world analogy? In this case, I'd like to use a baking analogy. So when we're making biscuits or crumble topping, we start with two base ingredients, sugar and flour. We add the fat, and we end up with this kind of heterogeneous material. So we take what was originally very uniform materials. Each sugar grain is very similar size and shape with its cousins, and the same with the flour. And we mix it with fat, and we get a very non-uniform or heterogeneous shape. So we've created crumbs ultimately from flour and from powder and granules. The same process is happening in the soil, equivalent process happening in soil. In this case, we're mixing our base ingredients, sand and clay, which are ultimately just ground up rock particles. Then we add a binding agent, in this case things like polysaccharides, and we create crumb structure. Ultimately, we create that heterogeneous aggregation we all look for. And we might ask the question, well, where does these polysaccharides come from? Just like where do the fats come from? Well, they're produced by organisms. They're produced by bugs and the microorganisms living in the soil, like bacteria and fungi. They produce these sticky substances which basically glue together the individual disparate soil particles into crumbs that have a varying size. So what's the big deal with aggregation? What do we care about them? Well, ultimately, the first thing is that those aggregates create pore space inside the soil. The soil goes from a very solid, dense structure to a loose and open structure. It has improved soil infiltration and improved water holding capacity. Yeah, it's also better aeration, so air can pass through the soil matrix, so we get gas exchange from the air and into the soil. We're also increasing the surface area of the soil internally. Yeah, so this is an opportunity for water films to collect. We can think of the soil as a giant subaquatic environment. It also produces a very natural fine till, so it's easy to work. And within those individual aggregates, we have a low oxygen environment, a controlled oxygen environment, controlled environment. So why is that important for farmers? Well, as farmers and gardeners, we all know about the sort of benefits of legumes. And one of the main things about legumes is they produce these root nodules, these kind of swollen beads on the roots. And these are basically the homes for nitrogen-fixing bacteria. Well, these nodules are almost directly analogous to aggregates. An aggregate is kind of a sealed blob, basically, and inside it there's a low oxygen environment. And we need that low oxygen or anoxic environment for nitrogenase, the enzyme that is responsible for fixing nitrogen to function. Yeah. So actually, the aggregates provide homes for free-living nitrogen-fixing bacteria. Yeah. So this is what we were talking about when we're talking about the nitrogen cycle or mineral cycles, nutrient cycles in the global context. Is that we have the opportunity to pair with organisms that are doing nutrient acquisition for us, basically. So if we're going to use a measure to indicate how well aggregated our soil is, we can use the infiltration rate test. We also use the slate test, which we will look at in more detail. Also the bulk density, so a measure of the volume of the soil compared to the weight. So the lower the density, the more pore space, therefore the better the aggregation. We'll also look at the best test. Okay. So the next key insight we might look at that underpins all of the soil health principles is this idea that microbes matter. Yeah, and that is because microbes structure soil. Yeah, they create aggregates to support loose structured soil for roots to patrol and easily occupy. They also feed plants by accessing nutrients, and they can do that by nitrogen fixation, and also by the process of mining out the minerals from the sand, silt, and clay, which are rich in minerals but in a form that plants can't access. And the final one is that microbes protect plants, actually ward off pests and diseases, and outcompete pathogenic organisms. So the key thing about nutrient acquisition or feeding plants is that microbes create a bridge between those inert or mineral nutrients and the types of nutrients that plants can uptake. This particular example is mycorrhizal fungi. The white thread-like structures that we can see here almost look a little bit like the lung. And they have that same function as the lung, in that basically they are able to access very low concentrations of nutrients over great distances and over large surface area. So that very fine structure is a very high surface area to volume ratio, in the same way that the lung does. And if you open out a lung, it's the size of a tennis court. So in this case, the mycorrhizal fungi is a fungi that creates a symbiotic relationship with plants. So it fuses with the plant roots, and the plants and the fungi become one. And the fungi basically supplies the plant with phosphorus and water, as well as other nutrients. So another example here of how microbes protect plants. And this again is another example of fungi. So this white structure here is a single fungal hyphae, and these formations here are called snares. They're baited structures, basically attract, in this case, root knot nematodes or root feeding nematodes. And these are an issue with potatoes and bananas and other crops, because they basically burrow through the walls of the roots, creating entry points for diseases. And in this case, the mycorrhizae is basically attracting, snaring, and then digesting organisms, passing nutrients up to the plant. So we can basically say that the plant's getting a pretty good deal here, isn't it? It's got loose soil for easy root growth, got its own built-in room service and on-site caterers, its own private doctors and plant health service. We're getting that all for free. As we know, there's no such thing as free lunch. So this is when we come to number one, the soil health principles. And the first one is that it's important to keep a living root in the soil for as long as possible, as often as possible. And that's basically because roots feed organisms, and they feed organisms through the production of root exudates, sugary substances that they secrete out through the roots that attract bacteria and other lesser organisms. And then in turn, the organisms nourish the plants. You're always going to find the best soil around the roots, because this is where the most microbial activity. If we look at this close up, you can kind of see examples here on the right hand side of a zone, a literal sweet zone around the root, basically coated with sugars and organisms, bacteria in this case. Wherever you have large numbers of herbivorous organisms, you get predators. In this case, on a small scale, predators are protozoa. These protozoa are motoring around, hoovering up lots of bacteria, thousands of bacteria a day. And as we all know, the byproduct of ingestion is excretion. So when you eat, then you shit. And what do you shit? And what do we call shit in the garden or in the farm? We call it manure. So we basically have manuring that's constantly going on in the root zone, basically plant available nitrogen. So we can say in this particular case that the plant is paying for nitrogen in sugars, because the sugars is the thing that the plant can produce by itself. So if we look at here on the left-hand side, this drop is an example of some of that sugary liquid that's being secreted by or exuded by a maize plant. So another piece of evidence we can look at when we're doing our spade samples, we can lift our roots of our plants and have a little look at what the roots look like. Typically, roots are white, aren't they? Everyone knows roots are white, except in this case, they're kind of brown. In that case, that's because they're basically coated with fine soil particles. We can say that this is soil building in action, and that basically we've got this happening. We've definitely got root exudation going on. We need those gels and slimes and sticky substances being produced to bind soil particles to the roots. Another example here, on the left-hand side, we've got a new root being produced, and again, small particles of soil stuck to it. So we've got small particle size and also stuck to the roots. But then we went asked this question: are all living roots created equal? Well, no is the answer to that. And in this case, we've got two side-by-side spade samples, both taken at the same time from the same soil. Left-hand side, we've got annual cover, and on the right-hand side, we've got perennials. So we can say that, like, in the short term, the living root kicks in more immediately. The effect of the living root kicks in much more immediately with annual plants. Yeah. So what are take-homes then from the living root? So we want to maintain the living root for as long as possible and as often as possible, particularly when we're in a cropping situation. We prefer annuals over perennials for lays and cover crops. And when cropping on a large scale, we're aiming for the 5-minute fallow to chase the combine. Okay. So number 2, we want to maintain covered soil. The soils want to be protected, and the organisms want to be protected. It prevents capping, it minimises runoff, promotes germination, and can also feed organisms, covering it with the residues. We've got an example here of a rainfall simulator. So what you can't see above this, these trays, oscillating sprinkler head that's just put out about 2.5 inches of water, about 20 minutes. So an absolute deluge, basically about a month's rain in about 20 minutes, just to really sort of demonstrate the difference. On the right-hand side in the middle, we've got 2 identical soils. Same field, same day, everything, except the one in the middle, after being put into the tray, it's had a light dressing of dry grass put on the top. So the buckets on the front, or the tubs on the front, indicate runoff. It's behind indicate infiltration. So we can see that simply by covering the soil and doing no other measure, basically, you reduce the amount of runoff by half or more. Yeah. And we can also see that, like on the front of this, the tray on the right-hand side, that sort of V shape. This is like there's a lot of soil on there, basically. So what we're seeing there is erosion. And in this case, what's really interesting is when the test is complete, they basically flip over the trays, turn them out so you can see what the underside of the soil looks like. And here on the right-hand side, basically, underside of this soil is dry, absolutely bone dry. Yeah. So it's not that just a small amount of water has infiltrated. It's not like some water has infiltrated, no water has infiltrated. Yeah. Despite there being a huge downpour. So this is what we're talking about when we're talking about the water cycle and scaling that up. So landscape scale. This is flood, erosion, and siltation. Then the need for dredging and all these other issues that we talk about. Okay. So what can we say then? So our imperative is to cover soil with leaves, growing plants, or residues. This is litters and mulch. And if you want to put a metric on that, we can use bare soil. We measure the amount of bare soil or the density of the sward. It is permanent pasture we're talking about. Okay. So the next one on our soil principles is to minimize disturbance. Number 3. Okay, because this preserves soil aggregates. It preserves the soil's crumb structure rather than breaking them up and grinding them down. Prevents slumping of the soil, so maintains that loose structure, and it also minimises weed germination. Okay. So this is when we turn to the slake test. In this case, basically, we place dried samples of soil into water. Yeah. Then the water then rushes into the pore spaces in the soil, so it rehydrates the soil, and in this process exerts a kind of outward force that serves to push apart the aggregates and the stuff that's holding together the soil. Yeah. So we can also call this the aggregate stability test. And in this case, in the middle, we have tilled arable soil. On the left-hand side, we have a no-till arable soil. On the right-hand side, we have a forest soil. And basically, we're saying that where the soil has lacking that kind of elasticity, the ability to absorb those outward forces that the water creates, it will slake or basically degrade, break down. So that's why we're seeing a whole load of sort of sediment down at the bottom of this soil, and also a lot of scum and murky water. You can say there's a lot of leaching that's gone on here. So just by going from no-till, till in the middle, to no-till on the left, we've massively improved the soil's ability to resist destructive forces. And obviously the forest soil does particularly well out of all of these. And what's really interesting about this is that you can lift the forest soil out, dry it, put it back in, dry it, put it back in ad nauseum. Whereas even the no-till soil, still, as soon as you try to handle it, it will break apart. So we can say that the forest soil is not only minimising disturbance, but it's also got covered soil, and it's also got a living root. So once we start adding these in together, basically, it's that these effects start to accumulate. Okay, so we can say that a suggested practice in this case would be using successional cover crops. So, for example, a 2-year planting of tall straw cereal with a biennial. The example that we're looking at here is rye and sweet clover. Both sowed together. And at the end of the first year, the cereal rye is rolled down, and the second year, the sweet clover will grow on. So we're maintaining that living root, we're covering the soil, and we're minimising disturbance. Okay. So we want to select disturbance seed drills when we're trying to enact this particular principle. We might be looking to roll cover crops, or as opposed to tilling them in, for example, we prefer annual cover crops over perennial lays, which perennial lays and grasses become much more destruction for cultivation to get an adequate kill. Otherwise, we would strip till essentially to living covers. So number 4 is to maximise diversity. With the diversity of plants or the diversity above ground means the diversity of microbes. Diversity of microbes means diversity of nutrients being accessed. Diversity of nutrients being accessed means better nourished plants. We'll look at a couple of examples here. So the first one is comparing spring cultivation in a horticultural operation. On the right-hand side, we've got 2 species grazing rye and vetch mix. On the left-hand side, we've got mixed species. So we can see on the left-hand side much finer till for crumb structure. Again, if we're looking at sort of a single way species here, again, we've got sort of little aggregation, quite a blocky structure with quite a lot of cracks, and then a small amount of aggregation just in the surface. We can put a number on this, we can put a measure. In this case, the visual evaluation of soil structure is that test. And generally speaking, the more crumbly friable gets a high score, and the more compacted, dense solid gets a low score. Okay, so we might compare this same test again. On the right hand side, we've got red clover green manure. On the left hand side, we have sort of a diverse cover crop. So people are saying we're having issues with the sound. I apologise for that. And if we look under the soil, basically, the red clover green manure has very little aggregations, very blocky, very solid, very hard to put spade in. You need to use both feet and lots of force. On the left hand side, we've got quite where we have the mixed species cover crop. It's very friable, crumbly, loose soil, and the spade just goes in with 1 foot like butter. And a similar process is repeated in the following year. Again, under the red clover green manure is blocky, solid, and cracked. On the left hand side, we've got a bit of crumb structure. Again, much of that may have been produced by the tillage past that was used before it was established, but at least it's maintained that. Okay. So this just demonstrates that diversity as we go from the arable to the lawn in the middle and to the hedge, again, they're progressively getting darker. Okay, so in this case, we might look at cocktail cover crops, a very high diverse annual species of cover crop, as well as the succession. Okay, so there's an opportunity for us to go beyond herbaceous in our diversity, and we can incorporate trees, like agroforestry plantings. And in this case, probably the primary advantage is that we are looking to pair up with not only the arbuscular mycorrhizal fungi, these are the ones that associate with forage plants, but also those ectomycorrhizae that associate with trees. So where the trees and the herbaceous plants meet, we have to overlap of both. So you're increasing the what's it called, the diversity. So I'm just going to see if we can do anything. Sound. Pause for a second. Gerard, are you hearing me okay? No.
Well, it varies in quality. I mean, I can understand what you're saying, but it's not the best quality, certainly.
Turn that off. So when you say it's not the best quality, do you mean it's breaking up, or
it's quite echoey, and there's it's slightly not very clear, really. Yeah. But it varies though, and I'm not quite sure if there's something that you're speaking closer to, or there's a connector that's slightly loose or something.
Switching over to a different. No, okay, well, let's just carry on. Maybe.
Yeah, that's the same, really. Yeah, still a bit echoey, and I mean, I can understand what you're saying. So,
Is it still echoey now? How are we doing now?
that's probably slightly better. Yeah.
Yeah, I've tried. I must say that. Let's see. If I turn off the video, will that also turn off the screen share?
I can still see your screen.
You still see the screen now?
Yeah, the video's gone, but I don't think that's important.
Okay, fine. Let's carry on from there in that case. How's the sound now? Any better? Any different? Okay, great. Thanks, Joanne. Anna. Right, so where are we? So, thanks for the feedback, everybody. It's good to know that you're out there. So in this case, just again comparing the soil under the tree strip or the grass next to the trees, and on the right-hand side, actually underneath the trees. And we can see, again, a small degree of additional aggregation. And that's indicated by the more kind of dried off areas, that higher surface areas drying off more quickly. Okay, so we can maybe sort of suggest, what this might look like, in sort of cash cropping situations or situation. In this case, they've really taken the diversity fever and pushed it all the way up to 10. And in this situation, they've turned what you might call quite sort of dense, blocky, heavy clay from permanent pasture into 6 inches of deep, well aggregated, and sort of more sort of brown topsoil. And this is given the fact that they're working on very heavy clay, north-facing, high rainfall on the edge of Dartmoor. So it's far from being the ideal situation for any of this. And they've done that through extensive mixed planting, hay mulching, and being no dig. Okay. So then our take homes from this is to maximise diversity in our plantings, our mixtures, layers, cover crops, and also cash crops. So looking to bi-crop or intercrop wherever possible and practical. In other words, and otherwise also expanding the rotation to introduce other different types of crops. Okay. So number 5 of the soil health principle is to feed soil, because ultimately no roots means no food, no exudates. Yeah. So this idea of feed the soil, not plant. Okay, so what eats stuff in the soil? Well, it's life. Isn't it? Ultimately, when we're changing over from one crop to the next, we don't want to make the soil organisms burn the furniture. Yeah, so if we've got this kind of situation, what's happening in here, or we're losing carbon, the organisms are chowing down on the only available organic matter that's in the soil, because that's what they eat. And most of the time, that stuff that's edible is the polysaccharides and other binding agents that they've used to produce the aggregates in the first place. So if this is allowed to continue, and then ultimately eat the stuff that's holding the aggregates together, and the soil will slump, so you lose that porous structure. And also, obviously, there's no carbon coming down into the soil either. Okay, so we're talking about that. How would we address that? We're looking to provide a subsistence ration for our microbes where we haven't got a crop, we haven't got the living root. So residues and litter, like straw and wood chip. manure, ideally straight out the back end of an animal, see principle number 6, otherwise well composted, or otherwise where applying compost, we want to be applying aerobically composting. On manure, for example, high carbon. Okay, so number 6 on the soil health principles is to incorporate animals, because they're trampling and they're grazing basically manures the soil, it massages the soil and helps to boost the growth of these plants, but only done using adaptive management. This is the critical thing, yeah. And we'll look at examples of that. So most orthodox management leads to decline of soil health, whereas adaptive management of animals leads to increase in soil health. Okay, so number 7 is to minimise the use of chemicals and synthetics. Ultimately, this undoes your good work previously. Yeah. The application of synthetics reduces root exudation, as well as suppressing and killing microbes. And the reason I write reduces root exudation is that once the plant is nourished artificially, it no longer has the sort of trigger to produce exudates. It's like, I'm fine, why don't I need to produce exudates? Yeah. And that's all fine during that stage as being fed through the uptake of those soluble nutrients. But those few weeks or months later, it means that the organisms that will have been associating with the plant will have gone dormant. Yeah, so you've kind of cut off the supply of nutrients long term. And otherwise, the application of chemicals will always affect non-target species. So, for example, the application of fungicides suppresses mycorrhizal fungal activity, as does tillage. So it has to be looked at in the round. And obviously, the application of wormers also affects dung beetle populations, and they all have an intrinsic role to play. Okay, so for under grass, like permanent pasture, for example, we might think we're doing pretty well. Yeah, we're ticking the boxes, we've got living root, soil, undisturbed, potentially some decent diversity, we're ticking all the boxes. Well, I might answer the question, well, how good is the infiltration rate on this soil? What degree of aggregation is present? What depth does that aggregation extend to? And how much of the pasture soil is actually covered? Yeah. Here's an example of an infiltration rate test that was done on Dartmoor last year, and it wouldn't infiltrate an inch of water in 45 minutes, even after the end of the drought. Okay. So we can say that infiltration is our primary issue. And here again, another example where infiltration rate was very slow, but then when we dig up the soil, look at the spade sample, we can see below 2 inches or so soil is bone dry. Well, let's say not necessarily bone dry, but touch dry. So we've got well hydrated surface layers, but very dry lower layers. And that same kind of issue was repeated recently on a site visit. So you can see a lot of standing water across the site, very squelchy. And yet, when we look at the soil underneath, it's touch dry from about, in this case, actually about an inch below. So you can see sort of wet on the surface, but actually the bulk of the soil is actually very dry. Yeah, just a quick one, Gerard. I think I'm probably going to extend a little bit beyond the previous finish time because of the extend maybe it's 5 or 10 minutes. Okay, so we can say that we can conclude from that ultimately management affects infiltration. We want to work with the latent potential of our plants. Okay, so we've got 2 samples here. On the left-hand side, a section of ground that was fenced out about 4 years ago, and on the right-hand side, down to orthodox grazing management. If we compare the infiltration rate from these 2 sides, that looks grazed on the right, inch of water infiltrates it to 220 seconds, which is not bad, generally speaking, which says pretty free draining soil. On the left-hand side, though, where it's been fenced out and the stock has been kept off, that same inch of water infiltrates in between 6 seconds and 25 seconds. A significant increase in the infiltration rates. Similar example, the same as we looked at initially, so 20 plus minutes from the grazed and 7 seconds from the ungrazed. So if we can look at these different management systems, we've said management ultimately has a massive impact. So here on the left-hand side, we've got what here we would call set stocking, so continuous grazing, lots and lots of runoff. Again, it's the same rainfall simulator examples above here. This sort of water sprayed out about 2 inches of water. Lots and lots of runoff. And one in the middle, we've got rotational grazing, so much less runoff. Yeah, good amount of infiltration. But once we move to a more kind of mob grazing situation with longer recovery, taller grass, we have much cleaner water and less what's called infiltration, so more water has been retained in the soil. Ultimately, our management directives here are to allow water to enter the soil profile, keeping more water on the hills. Yeah, storing more water in the soil means better growth in the season and no burning off. That's critical for us. Okay, so we can say then from that the management affects soil structure. Okay, the final one then, yes, the final one is management affects soil structure. On the left-hand side, so in this case we've got a herbal lake sowed in 2014. On the left-hand side, a strip that was fenced out in 2016, and the samples were taken in 2018. Again, sort of during that droughty period. And we can see on the left-hand side where it's fenced out, we have like very large plants, for example, lots of aggregation. As opposed to the right-hand side, we've got very dense soils and quite blocky. Again, so where it's grazed, even rotationally in this case, we have lots of bare patches, low sward density, and blocky soil. Opposed to that, it's been fenced out, well aggregated soil, high sward density, or no bare soil. The final one then is to say that management affects plant physiology. How we treat our plants affects their form. So on the left-hand side, in this case, we're looking at those same initial soil samples. So on the left-hand side of this particular tray, we've got 4-year rested. On the right-hand side, we've got this grazed. Yeah, so these are both coxfoot plants. So we can see that like, the way that they're managed massively affects the size, the shape, and the physiology of these plants. The same on the right-hand side, we've got again these fescue plants, both clipped every 4 weeks at different heights. So the root size of them on the left is just like streets apart. Okay. So final example from the uplands here in Cumbria. So on the left-hand side, we've got a ryegrass plant that's been rested for a couple of years. On the right-hand side, that's been grazed. I ask all of my sort of grazing clients the question: which of these two would you rather base your livelihood on? Both, and it's normally pretty categorical. That's the one on the left. Okay. So in this case, what suggested practice would be looking at, so more grazing is probably that primary indicated one, and as well as that, we can also be stitching in additional species to improve the diversity. But also, those could be the annual species, for example, to give a bit of extra growth, a bit of extra root depth, and also some more diversity. Okay. So as well as that, we can be looking at practices like bale grazing, where we have the animals out either in the autumn and spring or winter, for example. We can keep them on the land for longer, get more manure get more of that manure going directly onto the soil, and obviously save costs. Okay, so ultimately, what we're looking to do here is to tap into the latent potential of these plants. Plants dictate soil health. Healthy plants equal healthy. So if we want to put some numbers on this, we want to do some measuring for ourselves, then the Sector Mentor for Soils website is a good opportunity for you to access protocols or methodologies of how to carry out these tests for yourself. There's also an app that comes with it, but you can take photographs and also record all of these different measures. The final thoughts with an annotation request. So, I see, okay. So our final thoughts here is that the goal is to turn underlying subsoil into fertile topsoil through the action of plant roots and microbes. It starts with observation. Aggregation is the primary measure of soil health and it's easy to spot. And ultimately, we want to experiment with novel techniques to monitor those results. Our take-homes from this are that we should use the soil health principles to make decisions. This accumulation of small wins will really give us what we need. And we should let our management goals dictate practice. Don't be bound by technology or infrastructure. Here's a list of those soil principles: maintaining a living root on the soil for as long as possible and as often as possible, covering the soil, minimising disturbance, maximising diversity, feeding soils, grazing animals, and minimising the use of chemicals. So, so what's the relevance to us as natural, in terms of natural flood management? Well, ultimately, soil health, improving soil health is the only win-win solution out there. It's the only solution out there that brings production benefits, as well as flood reduction. Yeah. And for us to make it work, we need to integrate this into the centre of our field, the centre of our operations, rather than breeding measures, which are typically around the peripheries. Okay. So I just wanted to make some sort of brief mentions of land shape and the broader sort of context to this before we wrap up. So the first thing we can look at is making sure that any stream banks are protected from cropping and from soil. And the first thing we can look at is integrating riparian buffer strips. So this is a typical soil we might find, or pasture we might find in the UK. So where the animals have got unrestricted access, they'll basically graze up to the bank, and you have a lot of erosion. Here on the left-hand side of the top left picture, you can see a lot of erosion, and the stream bank is collapsing. On the right-hand side, where it's protected, they have nice, healthy riparian planting, it's growing by itself, and stream bank integrity. We look into it, incorporate buffer strips wherever they're planting. So this is a way to incorporate agroforestry systems. And then the other thing we want to be doing is to work with the lie of the land. This is probably the main way that we can eliminate flooding in year one. Ultimately, we're looking to eliminate flooding and surface water issues by land shaping, to redistribute water away from the damp areas and towards the dry areas, and potentially capture water.
Niels, we've only got a few minutes left. Will you be able to wrap up? Sorry to interrupt. Quite soon. Just got a little bit of time for questions.
Yeah, no, Jared, I wanted to carry on for just a bit longer because of the technical issues we had and the late start.
Okay, yeah, but yeah. Well, one thing we can do is, if you'd be willing to, we could answer the questions that we've received by on the chat and prior to the event by if you could answer them in written form, we can put them on our website.
Yeah, no, I'm happy to do that. That's fine.
Right, thank you.
So yeah, the final thing then is so rural sustainable urban drainage systems are definitely a functional part of a integrated natural flood management system. I definitely advocate for their use, but there's sort of one sort of slight caveat to that once the water's got into the streams, once it's already into the sort of flowing water, we've kind of missed the boat a bit, basically. Yeah, people can definitely access the slides afterwards. Again, we can use farm ponds to store some of this water that might otherwise be leaving the site. And that's a great opportunity for, or in this case, fishing lakes. Otherwise, could be for stock water and irrigation, etc. But the kind of important sort of insight in this case is that the water that's concentrating in the valleys began on the ridges. And the majority of the land is the ridges in the upland. Yeah. So if we want to deal with the situation at source, we want to deal with this, the cause of the issue, we need to be interacting on the slopes, the ridges, and on the high ground. Yeah, and this is where we can incorporate techniques like keyline agroforestry. In this case, what we're looking at is parallel rows of I'm not sure actually how I do take this here, basically, but we're looking at parallel rows of sort of a ditch and mound structure. So we've got trees planted on shallow ditches and mounds, and water would be making its way down here and focusing downhill like this. It's arrested in these shallow channels and then moved out because it's a very slight fall along this level, on this length, basically down towards the ridge. So the ridge, the valley's in the middle, where my is in here, and this is the ridge out here. Yeah, so the fact that these are all parallel and slightly off contour means that we've got water moving down and away from the valleys. And move on to the next slide. This is what it looks like from above, so a bit more of a kind of 3D view. The valleys are here, ridges are here, and the water is making its way this way. So we're redistributing water from the valleys out to the ridges. Yeah, and that means that we are evening out these sort of dampy, boggy bottomlands, and the drying off and burning off of those upper slopes. The last few go through, just to say that this is derived from key point. So here in this sort of green area here is where all the water is focusing from the upper slopes and then draining away and down valley. So if we capture water up there, a very cheap way to produce a dam and capture a lot of water and prevent that water also making its way away into the valleys. So then the final thing to sort of conclude, if you like, is that the sort of ultimate take home here is that we're looking to change the way that we think. Because if we change the way we think, we change the decisions that we make. When we change the decisions that we make, we change the actions that we carry out, and then the land changes. The land changes in response to the way that we manage it, and that will change what we can reap and we can take from the land, if you like. So ultimately, healthy soil, healthy plants, healthy people. So that's what I'd like to leave you with. Yeah, we're looking to encourage water to stay in the soil profile, store more water in the soil, keep it on the hill. Okay, so that's me. Very much for that, and apologies for the what's it called? Most of what was said was communicated, and again, I'm happy to share the slides with those that are interested, and also follow the conversation by email or on Twitter. If you want to jump back in, Joe.
Okay, great. Thanks very much, Neil. Really interesting and brilliant slides. Really good. And we'll make those available on the website as a recording. As we've just said, we've actually just come to the end of our planned slot now. So Niels has said he'll answer any questions that you've submitted in written form, and we'll make those available on our website. If people are willing to stay on for another, say, 10 minutes, Neil, so would you be willing to answer any questions here?
Yeah, absolutely. Yeah, no, I'm here.
Okay. Well, have you seen any that you'd like to answer? There's some in the chat.
Yeah, there's quite a lot, it has to be said.
Yes.
I wonder if which order which order.
I suppose ones that look particularly interesting, or maybe the easy ones to answer.
I want to make the point that land managers need to sort out poor soil structure, compaction, soil health issues, or starting changing management, introducing things like Mintil, electromagnetic. Yeah, so Bell, which one? I'm not sure, basically. Certainly there's an opportunity to incorporate things like subsoiling into a key line pattern, for example. So that same shape we were looking at, what's annoying, there's a out there, with the key line agroforestry. That also can be followed with a subsoiler, for example, so you can then be sort of alleviating compaction, and also water that's moving across the surface will be arrested in those very small channels and moved out along that same route. But I would always sort of like make sure that mechanical interventions aren't a substitute for best practice in management. Yeah, because you don't want to keep making it really bad and then try and fix it with subsoiling. But yeah, I would agree there's certainly an indication for mechanical interventions to give it a bit of a heads up. Emergent plants, beaver fans. Yeah, definitely beavers have got a place for this, and they make better suds, rural suds, than anyone basically, because they just what else is there? Areas, last place where priority wetlands, draining all these areas has been mantra. So yeah, certainly not encouraging any drainage of wetlands, not at all. I guess we're just sort of talking about reducing the amount of water that any existing wetland needs to cope with, by keeping more of that water on the hill. What else is there? What do we need to move from largely anaerobic?
One of the submitted questions was about benefit, or a couple of them were about benefits to the landowners. Might persuade them to change their farming practices.
Yeah, okay. Let's just try playing the video again. Yeah, well, there's I would say every metric of production benefits are there, with probably the main one being less disease in crops, yeah, because they're better nourished, so less expenditures on chemicals and nutrients, basically. Because again, if we're establishing relationships with organisms, we're tapping into the existing nutrient cycles that are there in a kind of latent form, basically. So rather than us continually needing to be supplying the plants with nutrients, they can basically ask for them as they need them. Yeah, so this is what we mean by the microbial bridge. Yeah, so you should end up with plants that nourish themselves and plants that are better protected from pests and diseases. So we're saving money significantly. Yeah, we're also, let's say in a grazing context, in 2018, for example, if you've got better aggregation, you've got much better infiltration. So all that water that fell on the hills and on your fields in the winter, a majority of that will still be there, or a much larger proportion of it will still be there come the growing season. Yeah, and that stored water is then a resource that the plants and the organisms can then draw on and continue to grow much further into the drought. Yeah, so burn off will be much later, and total dry matter production will be much increased because it's much hot, nice and hot and dry, basically. Yeah, we can capitalise on those really hot, dry periods rather than it becoming an issue. So all these people that were feeding first cut silage, they would be going on and grazing some more of the paddocks, taking second cuts, for example, and going on. But actually, we might also say that we've looked back and say those silage cutting practices also are reducing soil health. Yeah. Okay. Any other questions you managed to pick up on there?
Well, one interesting one I thought was that it just says where and how to start. Where if somebody wants to change what they're doing, where would they start?
Well, yeah, I guess it depends whether it depends what the context is. If they're in a pasture situation, then I would look at applying the pasture health principles, which we weren't able to sort of look at here, but certainly they're looking to shift towards more frequent movements of animals, for example, higher stock densities, longer rest periods, those kind of things. If they're in a cropping situation, then take your existing rotation, write it up big, and annotate that rotation with all the activities that carry on currently. Yeah, so when are the cultivations? What are the cultivations carried out by? When are the weedings? When are the applications of different inputs, for example? And then go through each of these different points of intervention and apply the soil health principles. Yeah, because anytime you're establishing a crop, for example, there's 2 or 3 different options on the table. Yeah, and ultimately those 2 or 3 options should be ranked against the soil health principles. Yeah, and those that score highest should be preferred where practical. Yeah, and if you keep doing that year on year, you'll reduce the number of cultivations, for example. You'll reduce the severity of the cultivations. You can increase the diversity of your cover crops, for example, and of your cash crops. So it's kind of like baby steps. But I would say that if you're in a cropping situation, next year, try 1 bicrop. Yeah, so look at sort of like doing pea and oat mixture, for example. So like do 1 bicrop. if you're cover cropping, then go from a sort of 3-way mix maybe to an 8-way mix, and compare that side by side with your standard. And if you're currently removing all your residues, then try straw chopping in one section of one field, for example, and get the spade out. In the season and see how the soil has changed, if there's any responses. But otherwise, you can go out and look in your fields and compare what it looks like in the middle of the field compared to what it looks like at the margins, maybe next to a hedge or something like that, and then that will give you a feeling for what the soil could look like if you change the management. Because ultimately, that's what we're looking to do here. We're looking to make incremental changes to management that accumulate over the years. Yeah, by hook or by crook, find opportunities to apply these soil health principles to all of your work. That's the take-home message.
Okay, great. Thanks very much, Niels. I think we better draw it to a close now. Yeah, thanks again. Really interesting presentation. I certainly could understand everything you said, and I've seen from some feedback that other people, whilst it wasn't perfect sound, I don't think it really detracted from what was really very good presentation. So thanks. Just to conclude then, if you do have any feedback or follow-up questions, please email us. The recording will be made available on the website, as will the slides. The next webinar, we're just finalising the date, but it will be by Dr. Andrea Montblanc, and will be on cover crops as a catchment management measure. And Andrea's from Corfield University. Details will be on our website. If you're on our newsletter mailing list, we'll also let you know about it via that. And apologies for the joining instruction problems at the beginning as well. We'll get that right next time. So thanks again for joining us, and hope you can join us again for the next webinar. Cheerio.